please take a seat. Okay, I guess we can start. So, ladies and gentlemen, colleagues, friends, it's my honor as a technical program chair to officially open today the 21st edition of the EuCNC conference, which is for the second year co-organized with the CG Summit. After 2 years of restriction of the COVID-19, we have the opportunity to meet again here in the wonderful city of Grenoble, paradise of nature, and also capital of the Alps, and the 2022 European Green Capital, and the most innovative city in the world in rank number 5. I would like to warmly welcome and thank all of you to making time to be here in person or by remote for people that weren't able to come here and travel to Grenoble. To be here today together, there's been a lot of hard work and dedication involved, a lot of commitment from the patrons, the European Commission, the French government, CEA-LETI, the CG flagship, the Grenoble College Management, the Grenoble Alpes Metropole, the steering committee and the technical program committee co-chairs, the local organizing teams, and you that choose to be active part of the conference. We have prepared for you a very dense technical program and social event agenda to make your stay absolutely intense and enjoyable. We have gathered a very high quality set of tutorials, workshops, keynotes, panels, special sessions, exhibitions, demonstrations, and technical discussion on a wide variety of topics related to the current trends of mobile communication from 5G to 6G. This year, internationally recognized experts from academia, industry, network operators, European Commission and government representatives will discuss together and stimulate and introduce new ideas contributing to the progress beyond 5G networks. I would like to especially thank the prestigious keynote speakers, the panel moderator, the panelists that will bring new vision towards sustainability and new technology challenges for the future of 6G networks. It has been a while since we did not meet in person. Let's enjoy it. Let's discuss. Let's plan cooperation for the future and experience in present life together. We are here to imagine the world tomorrow. We are here to contribute and discuss on technologies and strategy to provide connectivity for a sustainable world. Welcome to EuCNC and the 6G Summit 2022. I would like also to ask you, starting from 10, do not forget to vote for the best booth. You will have the possibility on the application of the conference to do that. Now I'd like to introduce our first speaker, Pearse O'Donohue, which is actually our chair, conference general chair and the director of the Fusion Network and the G-Connect and European Commission. Please, Pearse.
Good morning, ladies and gentlemen. Thanks to those of you who made it up early after the wonderful reception last night. So I would like also to welcome you with the grand title of co-chair, but Emilio has already thanked many of those responsible for the organization and putting this together. After 2 difficult years, it's great to see people again in face-to-face. But there's only one thanks that I'd like to add, and that is particularly actually to single out CEA-LETI themselves for the huge work that they have put in, Emilio and his team particularly, in making this possible. They've had to carry, shall we say, even more weight than usual in getting this year's conference together, and it's been a wonderful job. So thank you so much for that. And I'm going to get straight into my presentation in order to sort of set the scene as to where we are. So thank you very much. Those are my slides. Because what I want to talk to you about is really the shift this year from our focus in our research and innovation work towards 6G. But I can't help but start with what I do every year, which is the school report. Now, most years you have seen me put up the 5G action plan target. Of course, last year for the first time online, we put up the digital decade targets, which strengthened and continued the targets that the European Commission has set for the rollout of 5G in Europe, setting a further target for 2030, which is, of course, in terms of full coverage of all populated areas. But still we need, in the work that we are doing on deployment and rollout, still is very much focused on our 2025 targets, because we are aiming for comprehensive rollout of standalone 5G by that time in both geographical and sectoral terms. As you know, an awful lot of the work that you have helped us do in the preparation and development of 5G has been focused on the verticals and on the sectoral take-up, which is so important in our view in driving demand. So those are the ambitions which we have, and that is where a lot of the work, which I will mention very briefly now, that we are doing. But just if we look at, as I said, the school report card, how are we doing? Well, we have nearly 150,000 base stations. That may or may not be a meaningful figure, depending on what we know about 5G and its tendency towards small and smaller cells. But one of the KPIs or the measures that we are constantly using from the point of view of the European Union is population coverage, where we have now just reached 64-65% of population coverage, of course concentrated in urban areas. And that is important, but it is still a sign of more to do, because as we know from every generation, it is the last 20, 15, 10, 5% of population that are the most difficult and the most onerous to cover. But at the same time, we only have just over 50%, 56% of the 3 pioneer bands assigned. And what I mean by that is in terms of licensing assignment in each of the member states, it's done individually. Of the total capacity that is available, only 56% assigned. And clearly that is not enough. It is either a reflection of or the reason for the fact that most of the really interesting developments in the European Union are in the 3.5 gigahertz band, where most of the licensing has been done and where we see these new innovative applications. But of course, we're still missing out, as it were, on the applications in the millimeter wave that we've seen elsewhere, and we can also see when we look at other regions, which is what I'm going to do briefly now, very quickly. Obviously, my slides will be available afterwards, but just a quick snapshot in comparison insofar as that is useful, where we see that not only in terms of population density in terms of coverage, but also then in terms of the gross number of 5G base stations and population covered, that Europe is not doing all that well. We're not at the back of the pack, but still, when we see what is happening in South Korea and when we see what is happening in China, clearly we have quite a lot to make up. What is perhaps also relevant here is the mix between non-standalone and pure standalone 5G, which is why that despite an early start, if we compare ourselves to the United States, that of course the reliance on non-standalone combined with, of course, a high percentage of fixed wireless access applications, that is something where we don't want to be, but obviously what we do need to do is to aspire to the best in class. So there's still a lot to do. We can learn from others, but also hopefully ensure that the rollout and deployment in Europe is what we need. And to do that, we have put in place several funding programs. Now, if there was to be a silver lining to the very dark cloud that was COVID, it was the fact that it brought Europe together, including in terms of putting on the table a massive financial injection to boost the economy, to allow reopening and recovery of the economy. In what was called the Resilience and Recovery Fund, there was a target, which was that 20% of those monies spent by the member states, invested in key areas, that 20% had to cover, or 20% of it had to cover digital applications. In fact, we got beyond that target. We got up to 26% of the total relating to digital measures. Now, of course, there was some double counting. There was also an even higher percentage target with regard to Green Deal and environmental climate change type actions. And in some cases, you had actions which were covering both. But that's fine. The important thing is that what it does allow is an extra injection of key investment in the rollout of networks, in connectivity, including multi-country projects such as the Cloud Federation, but here in particular, in this case, the work that we're doing on cross-border corridors, as well, of course, as a significant amount of national funding for connectivity and 5G infrastructures. So this has added itself to other funds which the Commission had already designed and which we're rolling out, particularly the Connecting Europe facility, which is intended for large-scale deployments of technologies in the transport, mobility, energy, and the digital areas. So the digital part of CEF has looked at large-scale deployments. We have activities with regard to vertical use cases, particularly the 5G corridors crossing borders, which will also help to deal, for example, in very, very large scale, not just piloting, but actual real-life rollout of seamless roaming, which is one of the issues that we want to be addressing as part of our work on edge, cloud, and IoT in the implementation of 5G. But of course, in particular then, focusing on 5G for its applications, its use cases, including in smart communities, where we are working, just as we did in the old days with Wi-Fi, we were working with certain communities, local communities in some cases, who have industrial activities or zones where we are piloting the rollout of 5G and 5G for verticals. So that funding is also there, but of course it puts, it is small compared to the total amount of investment that is still required from member states, but, and I stress this, of course, by industry, by the private sector, whom we still rely on, and our financial instruments are aimed at supporting the work that they are doing, the investments that they are making, and also filling in the gaps. Here again, this leads us, when I particularly think of edge and cloud applications, of what comes next. And this is where I wanted to focus, and certainly where we will be doing a lot of interesting things and having a lot of interesting discussions over the next couple of days here at EuCNC, which is moving beyond 5G, which is already, as I said at the start, is now the shift in focus in our research work, just as we, as I've shown you, absolutely focus also on the deployment of 5G, making it real for the European economy and society. But it's very important that we continue to seek a leadership position for Europe and European industry in the development of the next generation of communications technologies. If indeed it will be called a communications technology, who knows? 6G may be the last G, but I think I remember hearing that about 5G as well. What I can say is that even before we get there, that clearly we have significant changes, partially enabled and accelerated by 5G itself, particularly the shift towards edge cloud and the development of a compute continuum right up out to the edge where the data is generated or is processed or is used. And as I was just having a very interesting conversation just beforehand, which will also help us to tackle what will now become one of the starting points for any research that we, the European Commission, fund, and which any research which I hope you, the industry present, will hardwire into your work, which is, of course, the attempts to move towards a low-carbon economy. In other words, to have extreme energy efficiency in all elements, not just of the radio interface, but throughout the core in the entire seamless connectivity and compute ecosystem which we see coming in place as we work towards 6G. That is an essential element which we have to bear in mind. Looking at this move beyond 5G towards 6G, obviously there is global momentum. Obviously, again, our trading partners and our competitors are also heavily invested already in examining where do we take 6G. There will be a very interesting panel this afternoon, which I recommend to you, just on that question of the so-called 6G race, so I won't say much about it. And anyway, I don't think you can really see what's on this slide, but this is just to highlight that, of course, in North America, but particularly, of course, in Asia, we have very significant efforts already. But I will seek to focus on what's being done here without claiming credit for much of it, starting, of course, with the 6G Smart Networks and Services Joint Undertaking. But of course, we've had several national initiatives, precursors to the SNS, which have set the tone for 6G work and which I hope will bring us all together very quickly in this and in other fora. So what is the situation? It's obviously already out there in the domain of research and innovation. We don't have any declared commercial initiatives yet, and quite frankly, we'd be a bit concerned if we were to have those, while we still focus on 5G deployment, but also on what comes in terms of advanced 5G and the next release from the 3GPP. We don't have a globally established vision, and in fact, that's the stage where we are at now, where we want to ensure that there's cooperation and collaboration, particularly with regard to the use of resources, and also so that we do, as I've said, hardwire from the start a very, very high bar with regard to energy efficiency in the operation of the entire ecosystem. But what we do know, we have certain ideas as to what it will represent. Apart from immersive technologies, it will be the convergence and the putting together of the physical, the digital, and of course the human, as the human then can become again in control of her or his environment, and also then manipulate, exploit, and be immersed in the technologies while in control of them. Of course, there are different visions. That's healthy, that's useful. But what we want is that Europe works together, decides on the strategic vision, then on the technology vision, so that we do not fight with one another and that we are actually exploiting resources. So of course we have to go beyond what 5G offers for verticals. We have to look at the importance of other technologies like artificial intelligence and its implications for the entire softwareization, but the virtualization of all network and compute activities. And then the sustainability issues. So there are opportunities, but there is a big challenge. And that is the area where we expect you, the research and innovation community in this area, to take the lead. We want to work with you. There will be lots more EuCNCs, but let's hope that every year, if I or my successor does a scorecard, that we are best in class. That is the challenge which I put to you. It is a challenge for all of us. Because in terms of the global framework, obviously we have seen with 5G how security and geopolitics have come to play perhaps an inordinate role, but a strong influence on how we do it. And that is not going to change. In COVID, we learned about the dependencies we have with regard to the supply chain and how there is a massive backlog in orders for new hybrid and electric vehicles because of the shortages in advanced microelectronics. That's one example. We also saw with the 5G cybersecurity scare the reliance that increasingly all of these networks have with regard to the software component, to the reprogrammable, real-time adjustable versions of the technologies, but also of the architectures, including the core network, where vigilance will be necessary, where proper transparency and where necessary certification will be key, and where therefore we have to have a full understanding of the technology that is actually going to be driving all elements of our economy. There are massive industry opportunities and, of course, opportunities for new players. Some will see that as a threat, but of course that is exactly how the economy grows and develops. So we see new players, but some of those new players are actually not new, they're just new to this sector. They are already dominant in certain sectors of activity in the compute world. And that is a major challenge, maybe even a risk. Just as some are saying that despite the fact that we have two very healthy European global providers of network technologies, some in other regions see that as a threat. But certainly if we have hyperscalers, 2 or 3, who dominate elements of the compute environment, that can also be perceived as a, not existential, but certainly a geopolitical risk which we need to think hard about. And that is why we embrace the entry of new players, and why some of the efforts that we do in the European Commission is, of course, aimed at startups and new innovative players to actually make this ecosystem richer and more diverse. All of this will then focus back to the user. As I've said, the technology will allow greater involvement. It will surround the user. But in Europe, we have not hesitated in the past and will continue to do so, whether it is in data protection or whether it is in the ethics of artificial intelligence, to put the citizen, to put the user first, and to ensure that the technology fully respects the fundamental rights of all citizens, and dare I say it, of all humans. As we seek to work with partners in other regions, we must ensure that those standards are maintained. So lastly, and I'm sorry for taking so long, just to look briefly at our plans with regard to the development of 6G or research and innovation. The first thing is, of course, at the center, as you would expect me to say, the new 6G Smart Networks and Services Joint Undertaking, where the 6G Industry Association, European industry, is playing a key role in the planning and the development of the strategic and then the strategic vision and then the work programs in order for us to shift a gear into 5G plus and 6G, accelerating the deployment, but also already developing the innovation. I'm not going to say much about their work simply because it is going to be presented by minds greater than mine today and tomorrow, but it is essential to the work that we are doing on this compute continuum. And then finally, with the help, as ever, of Bernard Barani, my colleague, a vision of pulling together different people's views on a timeline for beyond 5G and 6G. And the only thing that we can say with certainty is that where we are today, that's us, where the star is, but there's a lot that is uncertain. But where we want to get convergence on the requirements as quickly as possible, as we then seek to develop, to conceive, and then actually to launch 6G system projects, which would actually have a significant foundational influence on the work that is being done with regard to 6G. And we hope to do that in a global environment. The ITU is supposed to deliver its vision early next year. And then we have a window of opportunity to 2025 at the very latest, by which time very important formational, foundational choices will have been made. And of course, as I've said, it is essential that Europe is there in numbers, industry as well as government, to shape those decisions. Again, as I said, the colleagues from the 6G SNSJU will have the opportunity to present their vision, but they are already working on their plans for research for foundational and radical technology advancement in 6G. And that is one of the reasons why, again, you are all here, because we hope that, and I mean this in the most positive sense possible, that you will all commit and be committed by the work that is going on in our research and innovation with the 6G community for the benefit of Europe. To conclude, rapid fire. Obviously, we have to get 5G deployment done, and we have to get it right, because that is a foundational basis for 6G success. We need to coordinate all of our tools. We are not averse to critical comment with regard to how we're doing it in order to ensure that we can do it even better. Those 5G digital decade targets are not nice to haves. They are essential if Europe is to meet its own targets and if we are to provide the technology for industry to develop. We need to accelerate towards full standalone deployment as quickly as possible in order to reap the benefits, but also in order to be able to conceive the 6G applications. And we are committed to that 6G, as you've seen from the joint undertaking, which is already in place, as you will be told more about. It's not business as usual. You'd expect me to say that, even if I said at the start I will say use the same slide every year. That's the starting point only. We need to be looking to the future, and how do we actually deliver on our vision? So, with the lessons of the last few years, we do believe, whether or not it's the last generation, that 6G will be different in the sense that it will be concerning the full compute continuum, but in the same way, we have to look at the full supply chain. That is why the work that the European Commission and the European Union is doing with the member states already on microelectronics, the CHIPS Act, where CEA-LETI is a key player named in the Commission's decisions as one of the 3 founding partners for this work on microelectronics in Europe. We have to have this joined up vision with regard to the next generations of technologies. So we have, as I've said, up to at most a 2-year window of opportunity. That is your window of opportunity, but it is also your challenge, which we put to you. And I hope that we will start the work here in EuCNC. Thank you so much for your attention.
Thanks a lot for this inspiring talk. And then now let me welcome René Lequepeys, the Deputy CTO CEA-LETI.
normally my slides are sent to the screen. Yeah, okay. I'm sorry. So yeah, we are. So thank you, Emilio, for the introduction, and thank you, Pearse, for your introduction on 6G. Hello, ladies and gentlemen. So I'm very honored to be with you today and to welcome you in Grenoble for the EuCNC and 6G Summit in the heart of the French Silicon Valley. Today I will talk about the need to have greener electronics for our increasing world of data. I will briefly, on one slide, introducing our research institute. Our mission is to create innovation and to transfer it to industry in good conditions. And CEA-LETI has been recognized for more than 10 years as one of the 3 most innovative research centers in the world. We could see some key figures about our institute. We were created in '67. So 55 years of history of transfer to industry. We have 2,000 employees, portfolio of more than 3,000 patents, 40% of which are licensed to our industrial partners, and that's an important figures in terms of proportion. Our research has created 74 startup companies and created more than 3,500 jobs. We are committed to innovation, mainly related to miniaturization and reduction of power consumption. All this is possible only thanks to advanced microelectronic processes. We have 11,000 meters square of clean rooms with more than 700 of state-of-the-art semiconductor equipment. The digitalization of the world and the economy is accelerating, and the health situation with COVID-19 is contributing to it. The digitalization brings new useful services. We need more electronic components, but 2 major obstacles are in front of us: energy efficiency and sustainable electronics. To face these 2 challenges, breakthrough innovation are needed. At LETI, we are aiming for an improvement in energy efficiency by 3 decades, by a factor of 1,000 by 2030. To achieve this ambitious objective, we must work simultaneously on 3 levels. Firstly, on semiconductor technologies, secondly, on architectures and IC circuits, and finally, in terms of system practices and new uses. I will start by presenting, I would say, the context with the trend of deluge of data that needs to be stored and processed. Then I will talk about the need to take into account environmental constraints and to drastically reduce the power consumption of electronic products. In the third section, I will present 9 avenues of research leading to greener electronics, and finally, I will conclude my talk. This slide illustrates the evolution of some key figures between 2010 and 2020. We can see a 10% increase in the world population, with 7.7 billion inhabitants in 2020, a 22% increase in electricity consumption. We have grown from 2 billion internet users and 4.5 billion internet users are expected in 2030. Internet traffic has increased 12-fold, and mobile data 200-fold. Here you can see that the expected exponential evolution of the number of data generated in the world, with more than 2,000 zettabytes in 2035, against 64 only in 2020, and barely 2 in 2010. It is useful to note that in 2018, 44% of the data was generated by machines. This figure will rise to 90% in 2022. Digitalization makes it possible to offer new services. The 60 billion connected objects in 2030, using numerous computing solutions, will provide new servicing having a positive impact on key areas such as health, housing, agriculture, factories, manufacturing processes, and energy networks. IoT, artificial intelligence, digital twin allow us to better manage our factories by optimizing raw materials or energy needs, by making it possible to manage intermittent and decentralized energy sources, by offering opportunities to design new materials and drugs. To manage all this data, computing plays a key role to transform raw data into useful data for services. 3 steps are necessary. The first step is the transmission of data to processing unit. Transport is done by wide or wireless connection or processed locally. The telecom community plays a key role in this part, of course. A second step is to store and process the data. The third step is to exploit the data, and massive use of intelligence, artificial intelligence, will be needed to reduce the proportion of dark data. Now let's move on to the second part of my presentation. Innovation is key and essential to develop sustainable electronics. This graph illustrates where energy is consumed in electronic devices such as TV, PC, tablet, and smartphones. Energy consumption is due to the production of those electronics devices, which represent 45%. The use of those electronic devices represent 55%, split between 3 main parts in white colors: terminals, data center to process the data, and networks. On this graph, we represent the computational performance in gigaoperation per second horizontally and the energy efficiency of the computation in gigaoperation per watt vertically. Each white point represents an existing integrated circuit, and we can see that the human brain is well positioned with only 20 watt and a very high computing efficiency. The bee's brain has a low computing power, but a very good computing efficiency compared to integrated circuits. This result, given by living organisms, have to become a source of inspiration for the semiconductor industry. In addition to mastering our electricity consumption to cope with the deluge of data without exploding the global energy demand, we need to limit the degradation of ecosystem and living conditions close to the mines where the necessary minerals are extracted. Our industry uses an increasing amount of rare materials and minerals that are sometimes difficult to recycle, and we have to find alternative solutions. We have to reduce as much as possible the need of rare materials in semiconductor technology. We also need to find solutions to lower the water consumption required to produce electronics chips. So recycling of electronic waste is still very new, and it can bring deterioration of living conditions, with recycling often being carried out in third world countries. We must therefore consider doing life cycle analysis of new product very early in the development cycle of future product to make the right choices. When we look at this periodic table, you can see in white the limited number of elements used in semiconductor industry in the 80s, in black the elements introduced in the 90s, and in red a large number of elements introduced after 2000. Today, the electronics uses about 60 elements, and the recycling rate of electronic waste is less than 15%. In addition, we sometimes have rare material on the planet present only in a few countries. This is the case of lithium, with Chile controlling 60% of the world demand, China controlling over 95% of rare earths, Russia controls 60% of palladium, and South Africa 90% of platinum. This can create between countries conflicts with the risk of price increases or economic wars. The situation creates a real threat to our industry. I will now show a solution to manage the expected deluge of data and achieve the energy efficiency expected by society. At CEA-LETI, we propose 9 avenues of research which can be combined for offering a gain of 3 decades in terms of energy efficiency by 2030. Due to the lack of time, unfortunately, I will not detail them, but do not hesitate to come back to us if you need more information. Here the 9 research tracks recommended by CEA-LETI are presented. They have been classified along 2 axes. Horizontally, we have a maturity timescale, 2 to 3 years for the short term, 3 to 5 years for the medium term, and 5 to 10 years for the long term. Vertically, we have identified 3 levels: semiconductor technology, with innovative concepts such as non-volatile memories for neuromorphic chips, fully repeated SOI, gate-all-around, and quantum based on qubit on silicon. On the second level, electronic architecture and circuit, we have 3 research tracks: silicon interposer and chiplet, new dedicated accelerators optimized in terms of power consumption, ASIC for AI to move less data, because moving data consumes 90% of the overall power consumption. At system level, we promote 3 research avenues based on edge computing, which had already been mentioned, new algorithm, and sustainable electronics. I will comment only the last one, sustainable electronics. At the production level, we need to reduce waste, water used, critical or difficult to recycle materials. At the IC design, we must change the computing paradigm and get rid of von Neumann architecture. We need also to acquire greater expertise on very low power consumption techniques. At the level of eco-design, we must work to increase the lifetime of electronic products and make them easily repairable. We also need to do life cycle analysis very early in the development of new products. We must also help to better manage the end of life to quickly improving the means to recycle materials from electronic waste. Given the importance of this topic, we decided at CEA-LETI to create a strategic eco-innovation program. I will now end my presentation with this last part. The trend is towards a continuous increase in performance in terms of speed, power, and consumption, and miniaturization. 2 philosophical approaches are possible. The first approach could be based on declinism, which is a pessimistic approach, consisting in reducing or limiting technological performance based on the fact that one could not believe that technology and electronic devices could help to contribute to solutions for useful services. On the other hand, some others are considering that based on sobriety approach, which is the athlete's approach, looking at maximizing performance with a given budget of resources, electronic devices and services will contribute to offer technology that help to build a climate-neutral society. I'm clearly in favor of sobriety's approach for bringing in new useful services, of course, but we definitely need to innovate for reducing drastically the energy and environmental footprint of electronic devices. I'm convinced that we need stronger cooperation between the 2 communities working on microelectronics and telecom activities. By doing that, we will prepare together the foundation of a much more efficient 6G network, limiting the global impact in terms of power consumption increase. CEA-LETI launched last year this new 6G initiative. New 6G is a think tank establishing strong link between microelectronic and telecom worlds while meeting societal expectations and sustainability requirements. If you want to learn more, please attend the new 6G workshop. We have a common challenge. We urgently need to capitalize on hardware and software advances to master global digitalization and to preserve the planet. Our research team at CEA-LETI are mobilized on this huge challenge, and you have seen that solutions to increase the energy efficiency by 3 decades have been identified. But it's still necessary to bring them to a high level of maturity and to transfer them to industry in order to ensure that they will be used and implemented in future products. So, thank you for your attention, and if you join the shared vision, join us.
So please let me now welcome, thanks a lot, René. Let me welcome Michel Combot, Chair of the Strategic Committee for Digital Infrastructure Sector in France.
Thanks, Emilio, and thanks for CEA-LETI for organizing this and giving me the opportunity to present a viewpoint from the industry on technological and industrial sovereignty. The digital infrastructure sector, which brings together manufacturers of network components and equipment, fixed and mobile infrastructure, and electrocommunication services operators and manufacturers of communication cable, is today the essential foundation of connectivity for all. We collectively need to rely on a secure, stable, and reliable telecommunication networks. This is a matter of prosperity and competitiveness, but also of sovereignty. French and European digital sovereignty, since we need to think as a 27-member group to be able to weigh against tech giants in the global competition and defend our vision. To that extent, the Strategic Committee for the Digital Infrastructures sector in France aims to take part in a transversal way in all industrial sector. Supported by both historical and new innovative players, it enables the development of the entire French and European industry. All sectors included thanks to the offer of ever more efficient and innovative services. The consultation and coordination work that we carry out is therefore decisive for digital transformation, fully oriented towards competitiveness and sovereignty. This vocation is reflected in the particular attention paid to research and development, notably around 2 areas of focus that we consider crucial. First, the common work with competitiveness clusters and research centers. Then, the collaboration between our sector and other industrial sectors. And finally, the inclusion in a transversal approach of a variety of players ranging from large groups to innovative SMEs. Moreover, our strategic committee is bridging the gap with the public policy makers. We are an essential partner of the French government 5G strategy with more than 750 million euros of public investment announced last year. We are advising the government on which technology or use case to support in order to strengthen the industry's sovereignty. The digital infrastructure sector's support for research and development is essential to enable innovation. In this regard, we regularly rely on competitiveness clusters and research centers in our work, both in the context of work on 5G to improve its performance and develop new use cases, and in the longer term as a work on 6G has already begun in research laboratories. Competitiveness clusters have become a pillar of the innovation dynamic and have a mission to lead regional ecosystems with the collaboration of various players. In terms of 5G, our strategic committee has built, in collaboration with these players, a network of platforms for experimenting 5G use cases. The deployment of experimental pilots testing new uses on the technical and operational levels is essential and attests to the sector's desire to offer concrete industrial application. Within the framework of this project, our committee has supported to date 15 platforms, most of them winners of calls for projects on sovereignty in telecommunication networks conducted by the French government. Our approach is thus fully oriented towards technological innovation, with the aim of making the link with future industrial vertical markets and enabling the advent of Industry 4.0, which is essential to European competitiveness and sovereignty. To make the connection with future industrial vertical market, it is now crucial for us to collaborate with other industrial sectors. At the foundation of digital uses, our industry is at the intersection of issues linked to a multitude of industrial sectors, such as automotive, energy, cybersecurity, or health, for which 5G and in the future 6G are eminently important. Creating synergies between our different sectors is something we want to see promoted, included at the European level. Above all, in a competitiveness perspective, these collaborations make it possible to determine concrete industrial application for technology such as 5G by involving the various players from the design stage. With this in mind, our committee already leads several collaborations with other French industrial sectors. For example, we carry out important work with the automotive sector through the French automotive platform to bring our ecosystem close together. Within this framework of this collaboration, major areas of joint work source of innovation have been identified, such as vehicle automation, experimentation with autonomous mobility services, or platooning. We can also mention our collaboration with the Industry of the Future sector for the development of Industry 4.0, for which 5G has a key role to play. To promote competitiveness and sovereignty, we therefore advocate for a true inter-industry approach, going beyond a vision solely focused on telecoms. We believe also this collaborative approach must all be linked by a transversal, even horizontal approach involving from the design of technologies and networks infrastructures or the interested parties, in particular innovative small and medium-sized enterprises. The development of 5G experimentation platform is a perfect illustration of this approach. We want to bring together all the players, telecom operators, equipment manufacturers, SME startups, and competitive clusters around this joint work to develop on a large scale the network infrastructures and uses that will result from it. To give a very concrete illustration on the three axes I mentioned, we can cite the example of the 5G Open Road project deployed on the Saclay Plateau in Ile-de-France. This experimentation platform for vertical uses from the competitive cluster systematic is a model of inter-industry collaboration, since it is coordinated by the French automotive platform and by Nokia, which is one of the leading manufacturers in Europe, so as to create synergies between the automotive and telecom industries. The platform also is a model of transversality, since although it is based on the work of major groups of telecom operators and manufacturers, and also based on the work of Stellantis, one of the major automotive manufacturers in France, it is intended to be opened, allowing SMEs to come and experiment with new uses. This logic is essential to allow the greatest number of people to benefit from the know-how of telecoms industry and network equipment manufacturers to better understand the economic and industrial challenges that will arise from future mobile networks. In this regard, we are convinced that while large groups are essential to our competitiveness, innovative SMEs are also the key to our sovereignty, and their inclusion on a European scale is therefore necessary. To conclude on these challenges of competitiveness and sovereignty, I can quote Thierry Breton, who already raised in 2020 a certain point that we fully share. Without an autonomous European capacity in microelectronics, there will not be a European digital sovereignty. The supply crisis that we have experienced and we still experience has highlighted the need to create an ecosystem dedicated to microelectronics and semiconductors in Europe in order to meet the ambition of industrial sovereignty that we all share on a European scale in an increasingly polarized global context. As you know, these components are more than essential for our industry, as CEA-LETI has exposed before, and those of partners. Having a design and even production capacity on European soil is therefore a prerequisite for common competitiveness. To that extent, we welcome the investment plan recently announced by the European Commission, and we are fortunate to have in Europe and France the vital forces and the high-quality companies in this field, but we wish to remain in the race. It will be necessary to continue and strengthen public support for this industry on which we all rely. Moreover, we are also supporting specific developments for the telecom industry. Telecom networks need special chipsets to enable the full potential of 5G and future 6G networks. And as CEA-LETI already exposed before, the chipsets are the key to achieve our standards of competitiveness and also sustainability industry. Several platforms in our networks have been created involving governments and private funds, and we really look forward to work with you all in order to push the bar a bit further. Thanks for your attention.
Good morning, ladies and gentlemen. My name is Ari Polttu, and I will be chairing the keynote session, the first joint EuCNC and 6G Summit keynote session of today. So, today the first keynote will be provided by Mikael Rylander. Mikael is the Technology Leadership Officer of Nokia. Mikael is focused on steering technology innovation for Nokia in this rapidly changing era of software-driven and open systems. He is responsible for driving Nokia's technology leadership and its technology strategy, as well as defining Nokia's long-term technology vision. Mikael guides Nokia's direction in critical future network technologies and architectures such as 5G Advanced and 6G. His team maps out the strategy for machine learning and data-driven systems, security and privacy technologies, and sustainable innovation. While keeping one eye on Nokia's future, he keeps the other eye focused on industry and global trends to identify the opportunities on which we can capitalize. Mikael's talk today is entitled Shaping 6G, the Evolutionary Path with Revolutionary Technologies. Mikael, the floor is yours.
Thank you. Yeah, you need to be careful what water you drink in these day and ages. So, ladies and gentlemen, as already said, I will have a talk on shaping 6G, the evolutionary path to revolutionary technology. But first, I would like to go back 75 years in time to 23rd of December 1947, where a team of science in Bell Labs in New Jersey made an innovation that then led to 3 Nobel Prizes. Anyone have an idea what that could have been? It changed the world, truly changed the world. I'm thinking about the transistor. The same year, another scientist in Bell Labs made a paper
he made a paper on cellular technologies, and he introduced the hexagon as a way to describe the networks and how to reuse capabilities in the networks. This gentleman was called Douglas H. Ring, and he sort of started also the industry which we are all engaged with today. The number 6 and the hexagon will be a recurring theme in my presentation, so now you have been warned. We have picked up speed since the 1947. We digitalized with 2G. We digitalized the access technology with 2G. We introduced packet with 3G and then 2G. We increased peak rates and throughput with carrier aggregation in 4G. We increased capacity, reduced latency, increased peak rates, simplified with standalone core network architecture by 5G. It is not just in our industry we see progress in innovation. Human augmentation, digital twinning, AI and machine learning, robotics. With 5G, we are now on the brink to see that the digital, physical, and human world are coming together. Did 5G turn out the way we wanted when we did the research? Have we taken the technology to the end of the road? Is there really a need for 6G? Yes, we need to continue to evolve the communication technology to pave the way for the future. So the Nokia 6G vision, a fusion of the three worlds will unleash the human innate potential. It will allow us to experience work and life in a new, powerful ways. The future application will benefit from distributed compute, intelligence and analytics, if we look at the traditional way for us to design and also measure networks, we look at scale and flexibility, capacity and throughput, reliability and latency. In 6G, there will become new values, new ways to measure. Sustainability, digital inclusion, and security and privacy. What can we then expect? Capacity and throughput, 20 times for the traffic growth, 10 gigabits per second, 1 gigabit per second wherever we need. Reliability and latency reduced to sub-milliseconds. Reliability 9 nines. And then nanoseconds when it comes to synchronization. Scale and flexibility, global coverage, true global coverage, 10 million devices per square kilometer, a true platform and service approach across the network. The value drivers, sustainability, zero carbon footprint networks, and 6G for a sustainable future. Digital inclusion, global connectivity will be a human basic right. Security and privacy, evolve networks towards fully trustworthy and resilient systems. "6G will be an evolution, but some of the technology will be a revolution. And if we now look at things will progress, we can look at video. We will move from 4K to 80K, to extended reality, fully immersive user experience. And then into 6G, holographic transmission. Digital twinning, from object like an engine to large-scale digital reconstruction like a vertical farm, into broad-based digital twins with real-time synchronization like a smart city. From data communication and control to very precise positioning to network with a sixth sense. Researchers in Nokia and Nokia Bell Labs has identified key technology areas, and I will walk that through now and give some of the examples where we do research in Nokia. New spectrum technologies, AI native air interface, network as a sensor, extreme connectivity, cognitive automated specialized architecture, security and trust. Spectrum technologies in 6G. To cater for 35% year-over-year growth in traffic, we will need to handle 20 times more of traffic in the networks. We need higher throughput, and for this we need new spectrum, and some of it has its challenges. We will need low band to really make sure that we get coverage. I'm talking about frequency around 460 to 694 megahertz. We need more mid-band, the new mid-band, between 7 and 20 gigahertz to be able to expand capacity, throughput, and peak rates in the network at the same grid as we have today. This will require innovations in massive MIMO. Maybe we will see radio units with maybe like 10 times more antenna elements than we have today in 5G. And then sub-terahertz frequencies, between 90 and 180 gigahertz. This will be needed to get very fast throughputs, 100 gigabits per second. Of course, propagation here will be a challenge, so a lot of research is needed. AI native air interface. We need machine learning and artificial intelligence to optimize the air interface. Performance by bespoke waveforms, new constellations, and pilot signals that needs to change on the fly. We can see potential to reduce energy transition, energy. We can reduce the energy consumption in the radio unit by up to 50% by using AI and machine learning. We need to adopt for service needs so we can change and custom signaling and access schemes on the fly. The system needs to be very flexible and lean in every instance. Network as a sensor. This is really cool. So we will add another capability to the network, not just communication, but also sensing. The high frequency range opens up for this. We will use bouncing signals of objects so we can see their shape, how they move, and potential with AI and machine learning, what they're made of. This opens up for innovations for human security, but also new logistic schemes in enterprises and factories. Extreme connectivity. This gives a possibility to actually eliminate the wire, the cable, at least for short transmission distances. We call this INX, NX could be in robots, in production modules, and potentially in vivo. This will give flexibility. This will give us the possibility to handle very corrosive and hot environments, and can potentially also help us human to muscle control for disabled patients. Research on architecture. We need new architectures for sustainability, digital inclusion, and security and privacy. This will entail new cloud edge platforms, simplification, sustainability, flexibility, programmability, specialization, robustness, security, and native AI and machine learning. We look at a fully disaggregated network and architecture, a much finer granularity of microservices to really fast tailoring for our capabilities and the specific services needed. Security and trust. If future networks are not secure, they are not private, and we cannot trust them, consumers, businesses, and industries will never embrace them. As AI and machine learning will be more and more available, potentially technology like quantum and photonics compute, they will also be available for cybercrime. And we need to make sure that we are one step ahead. Lots of details, a lot of deep dives. This is the first announcement. We have now done an ebook and published that. And if you follow the QR code here, you can download it for free. This will give you an opportunity to dig deeper, but also to digest at your own pace. We're also shaping the future in Nokia through ecosystem build and collaboration. And you can see examples on this slide. I would like to take the opportunity to highlight two. Nokia is driving the Horizon Europe Smart Network and Services through partnership proposals, through the leadership of the SNS task force, and chairmanship of the 6G IA board. We also lead the HEXX, the EU flagship research initiative with strong participations from CSPs, major industries, SMEs, and academic stakeholders. The goal here is to develop a foundation for 6G for industry consensus beyond 5G. We are also working with CSPs and industry peers in research collaborations. With AT&T, we do research on distributed massive MIMO, and are looking at removing the cells, at least for a spectrum less than 20 gigahertz. In Arena 2036, we are working with near terahertz communication and also the sensing. We have now done a press release with Docomo, an entity. So together, we will bring out the 6G vision in forms of proof of concepts. We will do proof of concepts on AI native air interface and sub-terahertz communication. And I will now leave you with a message. 6G will liberate human potential. It will be done inclusively and sustainably. Thank you.
So, are there any questions for Mikael? It seems we have 13 minutes time, so until Coffee break. Okay.
So first of all, thanks a lot for your inspired presentation. I was wondering if you have any thought about which would be the bottleneck of the role of microelectronics in games. I mean, it's actually, I'm a system level guy, for example, either for working on a microelectronics company. What I'm starting to understand is actually we have a dream from the point of the system level. We consider that the hardware will make the deal. But at the end of the day, there's a huge problem when having the hardware make the deal with those constraints we want in terms of energy efficiency, in terms of cost, for recycling, and so on. Do you have any thought, any vision that you can share about that?
So I think in short, the question is, do we see the end of the road of the transistor, which I started the presentation with? Potentially. When we look at technology, we do see that AI and machine learning will take care of a lot of the challenges in sustainability, power consumption, and also size in the silicon. So we foresee that the technology as such will at least suffice through this decade and probably into the next. But we can also see that the world is making a lot of advancements in both quantum compute and photonics compute. So I think in centralized compute, we will see that more and more in the future networks.
Any other questions? No? Okay, Mikael, thank you very much.
The future is crystal clear.
And your message is crystal clear. Thank you, Mikael. And coffee break.